This is lecture 2.2 for Psych 440, Experimental Methods. Last lecture, we talked about the two disciplines of scientific psychology, experimental and correlational methods, and how IO psychologists use both to study behavior at work. In this lecture, we're going to review a little bit from your prior research methods course. We'll talk about the three strict requirements for making an argument that thing A causes or influences thing B. And we'll talk about why experiments are so important because they meet all three of those requirements. We'll also talk about the difference between experiments and quasi-experiments, which comes into play quite a bit when we're studying things in a workplace setting. We'll talk about the pros and cons of those kinds of designs, and we'll talk about examples of what this kind of research looks like in the context of IO psychology. Right. So we'll start by talking about causal arguments. It's very common that we want to be confident in knowing how things come to be. We want to be able to say that thing A caused thing B, or if you change thing A, it will have an effect on thing B. That's very important for the scientific purposes of explanation. Why did things happen? We need to know what the cause was, and control. If we want to change things in an organization, we need to be sure that the thing that we're changing is going to have an effect on the behavior we have in mind. So this is a very important goal for lots of areas of IO psychology. It's easy to identify that variables are related to one another, but it's much harder to be able to make those strong causal claims. So for example, if my company hired a new CEO and 2 months later we found that our turnover rate had doubled, it's very intuitive to link those two and say, wow, the employees really don't like the new CEO, they must be leaving. But that doesn't rule out all kinds of possible alternative explanations there. It's possible that the CEO came on board at the same time as a competitor's plant opened across town, and the competitor is paying slightly higher wages. It could be that the CEO's arrival coincided with a change in our benefits plan that made our employees less likely to stay with the company. So although it's not difficult sometimes to identify relationships between variables, it's much harder to make that claim that one of them really is the cause of the thing that we're seeing. In science, we've had consensus for many, many years that if you want to make a claim that thing A causes thing B, you need to meet these three conditions. First, you need to be able to show that relationship. Relationship by itself doesn't mean causality, but if there was no relationship between two things, it's really hard to argue that one of them affects the other one. The second condition is a little bit harder. We need to be able to show that thing 1 happened before, or thing A happened before thing 2. If our turnover rates went up 2 months before the new CEO arrived, it would be really hard to argue that the CEO was in any way responsible for that change in turnover rates. Time order sometimes is a little more difficult to show, but it's kind of in the middle. The hard condition to meet for making a causal argument is being able to completely rule out plausible alternative explanations. The problem is, as in the example with the CEO and the employee turnover rate, we could guess at lots and lots of possible alternative explanations. And sometimes we have the problem that a third variable is explaining the relationship we see between those two things. So, for example, if our competitor was in fact opening a new plant across town, it's possible that that variable might explain both the new CEO and the difference in turnover rate. We knew that this plant was coming, therefore we changed our business strategy, we brought in someone new to deal with the increased competition, and at the same time, from the same cause, we saw an increase in turnover rate. The more common example, which you may already be familiar with, is the idea of the cause of the relationship between crime rates and ice cream consumption. It's very difficult to argue that people consume more ice cream because they've just committed a crime. I find it incredibly difficult to believe that people who've just eaten ice cream would be more likely to go out and commit a crime. Surely they're contented and happy. And yet there is, to some degree, a relationship between those two variables. Well, the common explanation for that relationship, you've probably heard it before, is the temperature. In times of higher heat, both crime rate and ice cream consumption go up. When temperatures are cooler, both crime rate and ice cream consumption go down. So this is a challenging requirement to meet. It's very difficult to rule out all of those alternative explanations. When we start using the language of experiments, we often make a distinction between an independent variable and a dependent variable. An independent variable is the variable that does the causing, the variable that has an influence, the A in those examples of A causing B. In an experiment, the independent variable is the variable that we manipulate, that we assign people to. And that's where it gets its name. It's called the independent variable, not because it's unrelated to anything, but because it should be independent of whatever might have been going on with the participants before they walked into our study. So before they came to the study, they had no experience with this variable. It's unrelated to their age or their sex or the mood that they're in or anything like that. Independent of anything they brought with them to the study. The flip side of that is we also identify dependent variables. If an independent variable is the one that does the causing, then a dependent variable is the variable that is caused, or that is affected, or that is changed by the independent variable. So it's dependent because it responds to changes in the independent variable. Where it gets a little bit sticky for IO psychologists, as you'll see as we get into the next lecture, we don't always manipulate a variable. And technically, in the language of experiments, if we didn't manipulate it, it's not independent. So in other kinds of research, we might call the variable that we think is really the one influencing other things, we might call that an antecedent or a predictor instead. And in those kinds of studies, we call the dependent variable an outcome. So we want to be precise in our language, we want to use the terms of science correctly, but know that antecedents and predictors are conceptually very similar to independent variables. Dependent variables and outcomes tend to be very conceptually similar. The difference is we use the terms independent and dependent when we're talking about an experiment. We use those other terms when we're talking about a study that's not an experiment. So that leads us to an important distinction. See if you recall from your prior research methods classes the requirements for an experiment. Hopefully you answered there that the requirements for a true experiment are manipulating an independent variable, at least one, and random assignment of participants. These conditions are necessary for a true experiment because they allow us to meet those conditions for a causal inference. Hopefully, a successful experiment is going to show a relationship between variables. If we are manipulating the independent Now, within the general category of experiments, we can differentiate lab experiments and field experiments. What you're probably familiar with from other psych classes are lab studies. In lab studies, we have a very controlled environment. We might use exactly the same experimenter for every single thing. We have total control over what the participant experiences once they come into our lab. That control is the real advantage of lab studies. We often call this internal validity, the ability to really rule out lots and lots of possible alternative explanations because we know exactly what the participants experienced, what was the same, and what was different. The advantage of lab studies is that sometimes that control allows us to test things that we couldn't test in real life. So, for example, there are a number of lab experiments where we're interested in studying how different kinds of job applicants are perceived. So, the researchers might create two identical resumes with exactly the same credentials, same degree, same GPA, same work experiences at the same places, and the only thing that might vary on those resumes is whether the name at the top of the resume is a traditional American name or, say, perhaps a Middle Eastern name. Participants in the lab study would then rate only one of these resumes as in terms of whether or not they're a desirable job candidate, someone we should invite back for an interview. If you find a difference, if you find that resumes with traditional American names are rated more highly than resumes with traditional Middle Eastern names, the only thing you can attribute that difference to is the experimental manipulation of the name on the resume, because everything else is exactly the same. We couldn't do this with real job applicants because it would be impossible to find two people whose credentials really were exactly identical. Even if there are very trivial differences, people might explain it away and say, well, no, it wasn't bias. It's that this person worked for this particular company and I really value the way they train their employees, so I know they were just extra good. Those trivial differences could turn into alternative explanations. In a lab study with fictional people, we have total control over that, so we're able to isolate that thing that we're interested in. However, the downside to lab studies is that they tend to have trouble with what we call external validity. By the time we've isolated that particular behavior, you could say, well, that's really far removed from real life. You've now created this hypothetical job candidate who doesn't really exist. You have this artificial situation where people know that they're not really making hiring decisions. We call that a lack of external validity, lack of correspondence to the real world. So, we might conduct that same study using fictitious job applicants trained as role players. We might find a person who looked very traditionally American. We might find another person who looked very traditionally Middle Eastern. We might find the same person and just vary what they wore to look more Middle Eastern versus looking more contemporary American. We might have that person take an identical resume in and apply for jobs in several retail stores. And we might track whether that person is called back or not. Again, especially if we've got the same person playing both roles, we say we've controlled pretty much everything it is possible to control. But then we run into some ethical challenges. In a field study, it would completely defeat the purpose of the study if we went in and told the hiring managers, we're going to send in a job applicant in a minute for a research study. Would you mind telling us what you think of them? When they know it's for a research study, they might change their behavior. They might not respond as they normally would. It's also more difficult in the context of field studies to maintain confidentiality. Very often it's not possible when we're working with employees to guarantee them anonymity. We might need to track which department they work in. We might need to collect some information that could be identifying, and that's a potential concern for those employees. So they might have very legitimate concerns about whether or not to participate. It might be difficult to obtain truly ethical, informed consent in a field study. Another challenge with experiments in IO psychology contexts is that or there are some factors that we literally or ethically cannot manipulate. For example, we're very interested in how gender and race and disability status might affect how people are perceived in the workplace and how they experience the workplace. Those are not things that we literally could manipulate, or things that we would be willing to manipulate ethically even if we could. We can't assign someone to any of those things. Sometimes there are simply practical considerations. In the example I gave earlier about training techniques, it might not be feasible to randomly assign people. If you randomly assign people who work in the same department to different types of training, you have to expect that they're going to talk about the differences between those types of training. They may feel it's unfair. Why didn't I get a choice? Why do I have to take this training that I really don't like when my friend who works at the next desk gets to take this training that looks really cool to me? Those are very practical issues that IO psychologists have to contend with. In these situations, we often conduct what's called a quasi-experiment. In a quasi-experiment, we still manipulate a variable, or we look at groups that may differ naturally, so we're still comparing, but we don't randomly assign participants. The challenge with a quasi-experiment is that it doesn't quite satisfy that requirement of ruling out all possible alternative explanations. So, as an example, imagine that I'm interested in studying the effect of shift work on safety. I know that third shift employees, those who work the overnight shift, often have poor sleep quality, poor sleep schedules. I know that fatigue plays a big role in accidents, and so I might have a hypothesis that working on the third shift creates more unsafe conditions, is more likely to lead to accidents than working on the first shift, the daytime shift. The problem is, I can't practically go into a company and randomly assign half their employees to work first shift and half to work third shift. People have lives, they have expectations. I'm going to have massive dissatisfaction and probably a lot of employees quitting at this point. Especially if I'm taking somebody who asked for first shift and randomly assigning them to third, they're going to say, no way, that's not what I agreed to do when I was hired. Well, so I'm going to have to deal with their naturally occurring first and third shifts. I might collect my data and find that yes, the accident rate is much higher on the third shift. But now I have this problem of alternative explanations. In most organizations that have third shift, getting to work a better shift is often a privilege of seniority or performance. You might start in the organization working a third shift and by dint of good performance work your way up into a first shift job. What this means is that now my employees are systematically different from the first shift to the third shift in ways that don't directly relate to what shift they work. My first shift employees tend to be my experienced, senior, high performers. My third shift employees tend to be my new hires, my people who are less experienced. You could very well imagine that the difference I see in accident rates might not have anything to do with sleep schedules and fatigue. It might just be a function of the difference in experience between those two shifts. So with a quasi-experiment, I can still predict relationships, I can still find relationships, I can still compare group differences, right? That difference in accident rates is real. You're more likely to have an accident on the third shift than you are on the first, but it's harder to pin down exactly why. So it's possible, if I'm trying to recommend an intervention, if I go into this organization and say, well, you need a sleep intervention for your third shift participants, you need to give them sleep training and teach them how to manage their sleep schedules better. If fatigue is the reason for the accidents, that intervention is going to work. But if the real reason for the difference in accident rates is experience levels, that sleep intervention is going to have no impact. So quasi-experiments can give us some good information, they can be very helpful, they don't always tell us exactly what we want to know. So for next time, we're going to talk about correlational methods, which are also very useful for getting information that we can't get with an experimental design. Addressing variables that we can't manipulate, that we can't randomly assign across groups. We'll talk about the role that those play in IO psychology next time.